Today, the little topic, not my favorite, it talks about growth and decay. And by growth, they kind of mean like, when you talk about growth and decay with some things, it is usually growth by, I don't want to say exponential, but maybe it is. The book calls it a geometric growth. It's a geometric sequence, which means when we talk about growth and decay, the constant between things is always going to be some sort of a multiplication or division thing. It's called the constant ratio. And you'll understand when I give you an example. Okay, it's multiplication or division. In other words, here's the thing here. If you start off with 2 bacteria things and they double every minute, okay, what happens is the first minute you have 2, you double it, the second minute you're going to have 4, the third minute you're going to have 8, the fourth minute you're going to have 16, the fifth minute you'll end up with 32. It's like exponential growth. In other words, it grows slowly at the beginning, but as you get farther and farther away from the beginning, when you start doubling bigger numbers, it grows quicker and quicker and quicker. Okay. The key, though, that when you find that, same thing with decay. If something is rotting or going away, and it goes away by like half, if it starts out being 1,000, okay, and it decays, the constant factor is 0.5. In other words, it gets cut in half every time. You know, you go from 1,000, cut 1,000 in half, you get 500. Cut 500 in half, you get 250. Cut 250 in half, you get 125. Cut 120. Did I do that right? Cut 125 in half, you get what? 64.5. 64 in half, you get 32.25. Decay gets smaller and smaller. By the way, will they ever get to 0? No. Yeah, you'll get awful close, but never. If you did this a bazillion times, you will never, ever, ever, ever get to 0. Did I do that wrong?
No, I'm just wondering what it was.
2.5.
You can't do that math, Alex. Half of 64. Huh? That's what happens when you go to the orthodontist. Half of 32.25, can you do that? How about 16.125? Is that right? Half of 16.125? 8.0625?
Yeah.
Yep,
Half of that
totally.
is 4.03125. Half of that would be what? 2.0152625.
Oh yeah, ask Mrs. Nair to show you the video of the math.
Yeah. Oh, yeah.
I love the mathematician.
Have you seen it?
Nope.
He's really awesome. He knows numbers. He's
Now, here is going to be your dilemma, people. Let's say you're given this decay, which means the numbers are going down, and you're asked to give the next number in the sequence of that. 256, 192, 144, because here's where you're going to run into trouble, 108. What's going to be the next number here? Now, again, this is not by adding and subtracting. In other words, your first thought is to go, okay, to go from 256 down to 192, that is what? 64? Is that 64 or less? Yeah. Well, if you take 64 away from this, you don't get that. This has to be by a constant, which means by either multiplication or division. So you need to figure out what times this gives you this. And I just gave you the clue to figuring that out. How do I find out what times this gives you this? Well, let's write it mathematically. 256 times what number gives me 192? And that's going to be the constant that you use. Well, I guess sometimes math is ugly. quite often math is ugly. If you're given that and you wanted to figure out what would be the easiest way to get this down to something that might be worthwhile. Your two choices are either reduce the number or divide it out.
Reduce.
Let's cut, well, since they're both even, let's at least cut it in half. Half of 192, half of 256.
128.
Cut them in half again. Half of 96 is
48.
half of 128.
64.
Oh, these numbers are starting to look nicer now. What goes into 48 and 64?
6H.
Divide them by 8. You get 6 over 8.
Wow.
This ends up being.
3, 4.
So, in other words, to go from this to this, I multiplied, you can either multiply by the fraction 3/4 or by the decimal 3/4. You're going to get the same thing. If I multiply this by 0.75, I get this. If I multiply this by 0.75, I get that. If I take 108 and multiply by 0.75, I'm going to get the next number there, which is what? 0, 0, 1. Oh, look, 81. That would be the next number. So anytime you want to find what that constant thing is, just make an equation like this out of it to see what you multiply by to get that next number. Same thing with this one. How about this? Right out of the book. 16, 24, 36, and 54. Okay, what is going to be the next number there? And you might be able to find it by looking for a pattern here, but you really want to find what am I multiplying 16 by to get 24? 16 times what number is 24? Divide by 16, divide by 16, 3/2. I am multiplying by 3/2 every time, or 1.5. So if I take 54 times 1.5, I'm going to get, God bless you one and all. Oh look, is it going to be 81 again? It's going to be 81 again. Now you look, there probably is a, what's that, did you get wrong? There probably is some sort of a pattern if you did. This is plus 8. What's the next time, what am I adding? Plus 12. What's the next time I'm adding?
12,
Plus 18. Next time I'm adding plus 27. Is there some sort of a pattern when you, this is 4, that's 6? Oh no, this is 9? I don't think you could do it that way. It probably isn't. You probably just have to look for that constant thing. And that's all growth and decay really is. It's just finding that number to do whatever. Let's actually look at one. Let's see if we can't do one, shall we?